All right, mathletes, so let's dive into these vertical asymptotes. So before we actually dive into the math, let me show you what we're going to be looking for, all right, just to make sure we have understanding. So let's say x equals 3, so notice I graphed that right here, x equals 3, and we're using our friends over there at decimals. So x equals 3 is this line here, and this line, x equals 3, is actually a vertical asymptote. All right, so usually we don't draw asymptotes, but I just wanted to draw it so that you could see what it is that we're talking about. All right, so we have this function, we'll call it f of x equals 2 divided by x minus 3. And when we graph it, here it is in red, what you notice is that when you get close to 3, to x equals 3, look what happens as we get close to x equals 3 on the left-hand side. As we approach from the left, we're getting closer and closer to negative infinity, right? That function is just diving down. And as I get closer and closer to 3, I should say, from the right-hand side, look what our function is doing. Our function is shooting off to positive infinity, right? So let me be clear. As I'm getting close to 3, x equals 3 from the left, look what our function is doing. It's going to negative infinity. As I get close to x equals 3 from the right hand side, right, as I approach negative 3 from the right hand side, this graph is going up to positive infinity. So when you see this happening, as x approaches some number and you see the function shooting up to infinity or down to negative infinity, what you have there is a vertical asymptote. All right, and if we look at the relationship here, let's look at the original function. Notice our vertical asymptote was at 3, and you could see that if I were to actually plug in 3 into my function for x, you would see that you would get a division by 0. So that's the game plan. What we're going to be looking for when we're looking for these vertical asymptotes, we're going to be looking to see for what value of x does our function, our denominator, equal 0, right? And that's what we're going to be looking for when we're running through our calculations. All right, so let's dive into the calculations now. Follow me. All right, mathletes. So before we get started, don't forget to smash that like button, subscribe, and tell your friends what we're doing over here in Dr. Math Studios, right? We're working hard trying to help you get that A. All right, so identifying vertical asymptotes, and what we're gonna look at today is for rational functions, right? So rational functions means, we have a function where there's a fraction, right? Rational, that means fraction. So if we have a fraction here, what we're concentrating, just like we just said, we're concentrating on what's going to make that denominator equal to 0. Later on, we got to be extra careful because we're going to see some cases where we're going to factor the numerator and denominator, and we're going to see some cancellation happening. And whenever the cancellation happens, we're going to end up with a hole in our graph. But right now, we're just focusing on vertical asymptotes. So let's look at this definition so we could dive in here. So it says if c is a real 0, so if we have a real 0, then x equals c is a vertical asymptote of the graph f. And sometimes you read the definition in the book and you're like, what? Right? So all that means is that if you plug in a number here and it gives you 0 in the denominator, you have found one of your vertical asymptotes. So here's the secret, mathletes. All you're doing, it's this easy. You take that denominator and you set it equal to 0. You don't care what's in the numerator. You just set that denominator equal to 0, right? That's the whole idea here. And then we solve whatever's left over. So we're gonna go ahead and add 3 to both sides. We're gonna add 3 to both sides. And what you're left with is your equation of this vertical asymptote. So our vertical asymptote is right there at 3. And again, I brought in the graph so you could see that at 3, you have that vertical asymptote. And when we're drawing this, we usually represent it with a dotted line. And you could see that on the left-hand side, right, our function is going to approach negative infinity. On the right-hand side of 3, our function is going off to positive infinity. All right, so again, the big idea is we set that denominator equal to 0. So the big question is, well, what happens when that denominator is not so nice? Well, follow me. All right, mathletes, so let's look at part B here. And I'm not going to rewrite it again because Dr. Math forgot to hit record. No! All right, so what we're focusing on when we're looking for these vertical asymptotes is we're trying to see when is our denominator equal to 0. That's the big idea. But something I want you to write down and to encourage you, especially as you move forward, because we're all going to move forward, is I want you to try to actually factor this first, because most textbooks are going to, set the bottom equal to 0. But again, I want to encourage you to factor first, because what you're going to be looking for is to see if anything in our numerator cancels with anything in our denominator, right? Because when that cancellation takes place, that's when we're going to see a hole in our graph, all right? And later on, I'll make a video specifically on that idea right there. But right now, we're just focusing on these vertical asymptotes. All right, so I set the denominator equal to 0. And what I do is I'm going to try to factor this. So make sure your factoring skills are solid, right? So what I've done here is, I know it's crossed out because I recorded this supposedly. And so what I did is I picked two numbers, the 3x and the x, that would multiply to give me the 3x squared, and then the 2 times the 1 to give me this 2. And notice, I leave the signs out until the end. This is a pro tip, all right? So this is the fastest way of checking. So you multiply the middle, and that's how I got that 2x. Then I multiply the first number and the last number. So the 3x and the 1, the outer, I get 3x. So notice, the 2 and the 1 of these is going to have to be negative. So these signs are going to have to be the opposite. So when I'm looking at this, is there any way that I could come up with a positive 5x if these signs were opposite? Absolutely not. So that's why I cancel that out. And one note, when I cancel these out, I don't erase it, because as these get harder, right, you don't want to forget about everything that you already tried. And when you erase or scratch everything out, you tend to forget what you already tried. So this is a good way, just leaving it out there so you could see, all right, don't do this one again. And so now I went ahead and I flipped the 2 and the 1. So I put the 1 there and I put the 2. Try to ignore those signs for now. All right, so 1 times x gave me 1x, ignore the signs. 3 times 2 gave me 6. So how did I know what signs to put in there? Well, remember our goal. Our goal is to get a positive 5x. So what that means is that 6 had to be the bigger number and it needed to be positive. Therefore, that 1 needed to be negative. So how do I get that negative 1? Well, negative 1 times x, right? And then 3 times positive 2 would give me that 6x. And there you have it. This is our check. And remember, when you combine these two better give me that middle term. And that's exactly what they do. All right, so again, factoring is going to be huge in this section. So make sure you practice. If you need some videos, comment down below. We already have those for you. All right, so what am I going to do with these mother factors? Well, we just set them equal to 0 and we solve. This is the easy part. So we set this equation equal to 0. We added 1, then we divided by 3. And this represents one of our vertical asymptotes. And there you have it. If you look at 1/3, our invisible line there, we could see that as x gets close to 1/3 from the right hand side, this function is diving down to negative infinity, just like we expected, right? X plus 2, we set that equal to 0, and we solved, and we got x equals negative 2, which is another one of our vertical asymptotes. So what do we expect our functions to do? Well, we expect as the functions get close to negative 2, we expect them either to go up to positive infinity or to dive down to negative infinity. And that's exactly what we see here. So the question people might have is, how do I know if the function is going to go down to negative infinity or up to positive infinity? Well, you would just plug in a number if you were interested. In this question, they just asked us to find the vertical asymptotes, but if you did want to go that extra step, just plug in a number to the right of negative 2, say negative 1.9. And when you plug that 1.9 in here, you're going to see a large positive answer, meaning this function is going to go off to positive infinity. If you wanted to see what's happening to the left of negative 2, try negative 2.1. You plug that into your function, and what you would see is that you're going to get a big negative number telling you this function is going to go down to negative infinity. It's that easy, folks. Does that make sense? All right, follow me to our last problem. All right, Dr. Math, what happens when our function, right, the denominator, nothing cancels, and then what happens when the denominator does not factor? Well, we could solve, but you're gonna see some things, right? So we could use a quadratic formula if it's a quadratic, or if we're lucky enough, like in this case, we could just solve this, and you get x squared equals -4. And so I take the square root of both sides, right? I'm gonna need a plus and minus, but we have the square root of a negative. So we know that we're gonna have, just like a lot of your friends, this is gonna be imaginary. So we have plus or minus 2i. Don't start crying on me. So when you get an imaginary here, what that means is we are not gonna have any vertical asymptotes. And when we look at the graph down here, that's exactly what we notice. There are no vertical asymptotes. So again, when our answer comes out imaginary, what that's telling us is that there's no imaginary numbers here. No vertical asymptotes. All right, mathletes. So we're gonna leave you with part D. So let's make up part D for our good friends over here. So what we want you to do is comment down below. Comment down below. What do you guys think the vertical asymptotes are for part D? All right, so we're looking forward to hearing from you guys. Get your practice in. And again, don't forget to like, subscribe, and we'll see you mathletes in our next video. Peace.